Yeah, welcome to everybody of you. I think for you it's already almost close to the end of this SQL Saturday. I just woke up maybe 2-3 hours ago, so for me it's not early, but it's right after a nice breakfast on a Saturday. And I will immediately share my screen so we can jump into the session. Somebody let me know as soon as you see my screen.
Yes, yes, the screen is visible. Yes.
Thank you very much. Perfect. So welcome to Advanced Data Modeling in Power BI. I'm Markus, and I introduce myself the way that I say I work with models. I work with data models, of course, since over 30 years. But if I tell people that I work with models, sometimes they have different things in mind. They think I work with beautiful people, but indeed I work with beautiful data models. At least they're beautiful after I worked with them, right? Because naturally, like natural data is always dirty. We have to clean it up, and also natural data models usually are not optimized for what we need, for example, in Power BI. So before we even start with the advanced stuff, I want to make sure that everybody of you is aware of the basics. And the basics for Power BI Desktop and Analysis Services Tabular is the very same, right? Both are covered by the Vertipack engine. That means behind the scenes, there's the same tool, the same database. Hi, Hassan, how are you doing? So behind the scenes, it's the same database engine. That means everything we talk about data modeling, optimizing the data model, talking about DAX and things like that. It's the very same for Power BI Desktop and Analysis Services. You can even, if you start Power BI Desktop, load data into Power BI Desktop. If you start the task manager and look on the subtasks of Power BI Desktop, you will be surprised that there's a Microsoft SQL Server Analysis Services instance running inside of Power BI Desktop. So that's the same thing. And both are optimized for a schema. So this is a model-oriented tool, and they're optimized not for any schema, but they're optimized for a star schema. That means that the storage engine profits from the star schema. That means the compression is better, and also DAX. If you have to write complex or even rather easy DAX statements, if your data model is not a star schema, this could be very complicated or even be a nightmare. And the discussion here is not about if a star schema is superior about other data modeling techniques. That's not the topic. The topic is Power BI and Analysis Services is optimized for the star schema, and if you apply this way of data modeling, then your life and the life of your report users will be easy. If you're not applying, it will be harder. And other tools, they don't need a star schema. Other tools maybe want one single table. Think about paginated reports in Power BI. Think about Tableau. They want to have a wide table with all the content in there. This has advantages and disadvantages. And for some reason, Microsoft decided for the star schema optimization here. This also means that the relationships in the star schema, they are always a one-to-many relationship, right? We have one customer who can have hopefully many sales events, and one sale event can exactly be associated with one single customer. That's the one-to-many relationship, and it's optimized for only filter directions going from one direction to the other one. So if I filter the customer, it will filter the sales, and I only will see the sales for this customer, but not the other way around. If I filter, for example, the date on the sales table, it will not filter the customers available for filtering. If you need this, you can apply techniques in the reports, but you should not make your data model be bidirectional, where the filters go in both directions, because then the model will be slower again, and there could be situations where you cannot apply the same trick again to the next table you want to join, because you end up with an ambiguous model, and Power BI and Analysis Services will not allow to do that. So before we even started, before we come to the advanced stuff, I want to make sure that the many-to-many relationship, you should stay away. You should not use it. Detached tables, that means tables which have no relationship, no physical relationship between one table and the other one. You should not do that. And the key value pair model, as we will see in a second, is very flexible for the application developers, but this is a nightmare in doing report on it. And this is what you should avoid, and this talk is exactly about how to utilize those situations. But I've just wanted to make sure that you don't use this talk as an excuse to model many-to-many relationships or other things. You only should use it in very special situations where you're sure, you matured, you discussed, you thought about it, and then you came to the conclusion there's no other way than for example, using many-to-many relationship detached tables or treating a key value pair model. And this is the agenda for today. So we will talk about, or for the next 40 minutes or so, about the multi-fact model, about many-to-many relationship. In the multi-fact model, as we will see, I come up with an example about a detached table, and we will talk about what we can do about key value pair tables. It's not really a model, right? It's one table, but we will see in a couple of minutes. So multi-fact model means in a star schema you have a fact table, and the fact table is in the center of the star, and the dimension tables are around it. So with a lot of fantasy, I would say, you could see a star formed there. I think the term was introduced by Ralph Kimball. He had like nice ways of describing things, but sometimes I think it's confusing because I don't really see a star in the star schema. So I have my hard time with explaining why it's called star schema. But you could have like not only one fact table, but you could have several fact tables. And then some people speak about the universe and multi-fact tables because there's many fact tables. So one star, several stars form a universe. And you should, again, try to avoid this. If it's not necessary, don't build several fact tables, but you need to have several fact tables. For example, if the granularity is different. So one table is talking about like daily data, like the actual data. The Death Star schema, yeah, that's a good thing. I don't think I have this in this slide deck, but in another slide deck I call like what's the Death Star? What's the depth to a star schema? Which is, for example, a simple table, a single table, or the normalized and other things. Okay, so coming back to here, so if there's different granularities, then you would have different fact tables. So one is maybe on daily data, the other one is on monthly data, for example. And at least they should share one common dimension, because if it's like really separated fact tables, which even don't share any dimensions, any filtering or any aggregation on the same entity, and then you should not put it in one data model, but just make two data models out of that. And I think, this is my prediction, there is this preview feature called Direct Remote over Power BI and Analysis Services, which is an awful long name, so I'm excited to hear about what will be the name of this feature when it's coming to general availability. So GA means when it's general available. Currently it's still in preview. The feature is in preview since December 2020, so almost 2 years. I hope it will become available soon. That means you can try it out, but it's not supported. So if you're struggling with the features, Microsoft support will not be able to help you. And the idea is that you then connect. Currently, if you have Power BI, you can only connect to one single Power BI dataset or analysis services tabular model at the same moment with the live connection. But with this direct remote, it will allow you to connect to different models. That means that you build up your own galaxy inside of your Power BI report by connecting to this fact table and dimensions and the other fact table and dimensions. And of course, you will want to keep them together, for example. So this will be an exciting feature. And as no tool currently on this planet is allows you to do such a thing, we will see how we can. We have to learn how to use models like that, to have those proxy models, for example. The use case I came up with here as a demonstration for the next demo is a budget. So think about that the budget usually has a lower granularity than the actual data. So the actual data is on daily basis, the budget is maybe on yearly or quarterly or monthly basis, but most probably not on daily basis. The actual data is on product level, but maybe the budget is on the product group level. So that's what I came up here with up here. And I will demonstrate 3 different solutions how we can do this. There's one function in DAX which is called treat as. When I first saw it, I thought this is a Greek goddess, Triatas, but no, it's treat as. For some reason, we don't use Camel or Pascal keys for in writing functions or things in DAX, so this makes it sometimes hard to read or get the idea. So treat as, or the many-to-many relationship. We will see how this works out in this, or what I prefer is the bridge table. But long story short, we will jump into the demo. So what I came up here with is a very simple model. There's one sales table, as you can see here, and this sales table contains only 4 rows. It's a really simple model by intention. I want to keep this simple so we can we can concentrate on the more complex stuff and still understand what the complex stuff is doing. And we can see there's a product table and there's a relationship in between, and there's the product 100 and 110 and 20, and 100. So 130 is no sales and 110 is 2 sales, and then those products are grouped, group 1 and group 2. So the first 3 rows here form the group 1, and C is the only one, so group 2 is the only one where we only also have sales. The budget table has no relation to the product group, and in fact, if I jump over to the model view, you'll see here this is a more or less typical multi-fact model. So we have one fact table, the sales table, which has a dimension, is filtered with the date dimension in one-to-many relationship, and by the product dimension, because there's a product ID in both, and there's also this date in there. The budget has a different granularity, and just to make things easier, for the sake of this demonstration, I connect this per day. So the budget is filterable on the date level, which is not typical in real-world scenarios. But I just wanted to concentrate on one single complexity here, the connection between the budget table and the product table. And there is no connection, as you can see here, because I don't have a product ID in here. I only have a product group, and the product group in here is not the key there. So I could not create a one-to-many relationship, but a many-to-many relationship. And for the first way, I just wanted to stay away from this many-to-many relationship and show you what's the consequences of the current situation. If you build a report on this model, we can see I have 2 lines here. 2 lines because it's both for the month of June. Everything is in June, right? And the group 1 and group 2 is because there's 2 different product groups, right? So the group 1 consists of those 3 sales, those 3 products, 3,000 plus 20 plus 10 is the 33,000, and the 15,000 is the last one here. If you add this up, you get 48,000. Everything is fine as expected, I would say. For the budget, we get this weird situation that there's a repeating number. I mean, there could be a situation where we have for both groups the same budget, so this could be an issue or not. It's hard to tell. But if you see the total down there, we can see that there is a problem indeed, because 27 plus 27 is not 60. So something is wrong, clearly. So let's try to understand why we see these numbers here. So the 27 indeed is, if you take a look on June, of the June budget, so we have a budget for June and for July. And for June, we have a budget for the group 2 and group 3, and both of them form this 27,000. So the 27,000 we see here are those both lines. But maybe you think, wait a moment, Markus. I mean, we are talking about group 1 and group 2 here, and then you tell us this is the sum of group 2 and group 3. This doesn't make sense. Totally with you. This doesn't make sense, but there's no filter going from the product table to the budget table. So anything I select here, anything I show here, forms a filter context on the group 1 or group 2, but the budget table is totally ignoring this filter context because this filter is not propagated between the product table and the budget table. As you could see here, there's no filter in there. So this table is not filtering the budget table. So that's why we see the 27,000, because for June, we have in June, the date is filtering, right? If I select some dates here, this is filtering, this filter is propagated to the budget table. So I see 2 times the same budget, the 27,000, because I see 2 lines with June. The filter on the group is totally ignored when it's coming up to the budget table. So what about the 60,000 here? You should keep in mind that unless we explicitly ask for that, in normal situations, the total down there is never ever the sum of those single lines. The difference between the total and the individual lines in a table, for example, table visual, is that the filter context is different. So in this line, there's a filter context on the month, there's a filter context on the group, and this is respected by the sales table, and it's only partly respected by the budget table. So only the June is filtering the budget table, but not the group 1. The filter context is then different for the next line, and the filter context is also different on the total. So the total, the only difference between the total and individual lines is that the filter context is different. That means in the total, there's no filter on the month, there's no filter on the group. So that's why we get the 48. The 48 is not the sum of the 33 and the 15. The 48 indeed is a sum of all those 4 lines. And the same applies for the budget. So for the budget, if we add up the 20 plus the 7 plus the 25 plus the 8,000, this is the 60,000. So in this line, there's no filter applied on the month, no filter on the group. That means all of the lines are summed up, and that's how we get the 60,000. I hope this is clear so far. Andre makes fun. I might steal this picture, Andre. Okay, so back to that. So how can we solve this? One way would be this function treat as. So just, I know it's hard to tell if I say ignore the part up there, we concentrate on this. Of course, everybody will now look on this part up there, but stay with me. We will talk about this code in a second. I just wanted to demonstrate what's the difference here. So the budget is still the 27 with the 60,000 down there. And with this budget treat as I came up with, I can hardly solve the issue. At least we get now an empty budget for group 1. Remember, for group 1, for group 1 we don't have any budget. The budget is only for group 2 and group 3. So this sounds right. The budget for June in group 2 is 20,000. This is also right. But that's the 20,000 for group 2 and June. And for group 2 and July, we have this 25,000, which we can also see here. So this is partly better. We can also see that like the sum makes sense. The 20 plus the 25 is now 45,000. Because, yes, I just explained to you that the total down there is never ever the sum. It's just a different filter context. But still, we as human readers expect that this sums, the total makes sense to us, right? Otherwise, something is wrong in the system. But this still doesn't solve the issue that we have the group 3. We're coming to that later. So how did I build this this measure? This measure is just the sum of the budget. So this is nothing different compared to this column, the budget. This is only just the sum of the budget column. But I then used treat as, and this means treat the budget product group as there would be a filter applied on in the current filter context available product groups. So I take all the product groups available in the current filter context. So values comes up with a list of product groups in the current filter context. That means either in these individual lines, group 1, group 2, or no filter at all, and then apply it on the product group. So with treat as, I can create a filter relationship on the fly. So it's not available in the model, but it's available only for the sake of this calculation. So with calculate, I can come up with a measure and then come up with filter context modifiers, so to say. Filters, I can change the filters, I can add filters, I can remove filters. Here we create a filter depending on what's available in the product group and apply this on the product group on the budget table. So that's the good news here. But the bad news, we don't see the group 3, right? There's one way we can build this. The other way is, maybe you say, oh, I'm new to Power BI, I'm new to DAX, this is too complicated. I have a hard time in writing this code, I have a hard time in writing the code or understand the code, then we can still go there and then create this filter relationship between the group and not the budget, but the other group. So this will then create a many-to-many relationship. I get a warning down there, it's just a warning, I can still click on the OK button and tells me that's a many-to-many relationship. You should be aware of the consequences you're having here, and the consequences could be a slow performance and or more complicated DAX and or situations where you cannot add another table and then make it also a many-to-many relationship with a bidirectional filter, because this would introduce ambiguity to the model. In this case, I just ignore this and say, yeah, I know what I'm doing. So for some reason, this is inactive. This was not planned, so I want to make this active. And that's new. Can I create... okay, because I have to change this. I want to filter from the product table to the budget table, not a many-to-many relationship. And then it's okay again. So I have a many-to-many relationship now because the product group here and the product group here is not distinct. So there's duplicates here and there's duplicates here. But the filter is still going from the product table to the budget table. And with this change, we achieve a similar situation for the budget now. So I didn't change the calculation of the budget, but I changed the model. And the calculations are very depending on the model. As we can see, we see the same numbers for the individual lines, but you see the 60,000 here. And now it's the question, what's right or wrong, right? The 60,000 is right because that's the total of the budget. But some people could also tell us, no, the 45 is right because it's the sum of those numbers we're seeing here. The problem is we're not seeing group 3, right? So how could we solve this? And this can be done by the classical bridge table. So I close this and close up the other example. which is in here. The bridge table means that we build a table between those two, the budget and the product table. So the many-to-many relationship, I want to split into one-to-many relationship. So there's a many-to-one relationship then from the budget to the bridge table, and there's a one-to-many relationship from the budget from the bridge table to the budget, as we will see in a second. So this new approach would be creating a bridge table. You can zoom in here a bit. So this would be the new situation. I still have the budget table with a filter from the date table, so everything is the same, but I introduce this product group table with a one-to-many relationship to both the budget and the product table. So between the budget and the product, we still have a many-to-many relationship, but there's something in between which dissolves everything into a one-to-many relationship, which is the preferred thing here. And if you jump back here, we can see there's a filter relationship between sales and product, but there's also a filter relationship between product and budget. And now we get what I think the right number in all situations. So we can see that the individual numbers are right. This is the numbers we can see here. Depending on the date and the product group, we see the right numbers. The sum is the 60,000, and we also see the group 3 here, because I took now from this common product group, where is it? The product group table. Over there, the product group table now consists of group 2, 3, and 1, and this is formed. I mean, you can use Power Query for that, you can use DAX for that, which I did here, or you could build this in a data warehouse, right? You could use SQL to come up with a unioned list, distinct list of those budget groups. And what I'm doing here is a distinct list of the product group from the budget, a distinct list of the product group from the product table, union them. So I take the lists underneath each other, and there could be duplicates, right? Because with product 2 we have them both. So I again wrap it into a distinct. Any questions at this point in time? How and why to form a bridge table?
No, it's clear, I guess. No worries.
Very good, very good. Then we jump forward. There's no questions here. Galaxy scheme. Funny discussions in the chat. I like that. So 3Ds, just to keep in mind, because maybe you think, I don't build any relationships now in the data model. I don't bother with that. So I just do it with 3Ds. But this is dangerous because 3Ds is using a virtual relationship, so there's no physical relationship. And if you take a look on the data model with Vertipack Analyzer, for example, you will see that relationships occupy memory and space in the data model because there's a sort of index. Think about this, it's an index where all the combinations are formed and stored. So to make an actual filter pass through faster because this index is available. With 3Ds, there's no index because there's no relationship. The data model and Power BI and Vertipack didn't even know that this could be possible to join those two tables. So you're building this on the fly, and the active relationship will not be envy on you, but you will have to pay a price for that, and it could be the performance could suffer. And of course, your DAX statements are much more complicated because you have to write these 3Ds in every single measure you want to use. You want to use this relationship. So keep this in mind. This is not a solution for everything, but there's some sort of situations where this comes in very, very handy. I built this for in a data model where one of the dimension tables had 1 million rows, and it was not a big of an issue with 3Ds. So your mileage may vary. And now I closed the relationship, the slides. Jump forward, detached table. So detached table is similar to what we just have seen, that there is maybe no relationship between the table. There's no physical relationship in the model view. Again, be careful with that because this could come up with a performance issue. But while I need this, the only way where I can use this is if you have complex relationships in the terms that a usual filter relationship is an equijoin. So we can only apply where the product ID here is some value, and I want to find the same product ID in the other table. So the filter is on an equality expression. Product ID equals the product ID there, then I want to join those rows from these tables. If we need more complex relationships, like a range or some inequality or something, we cannot build a filter relationship in the model view, and then we can reach out for this concept I want to demonstrate next. I use this for binning. Binning means that we have values, and I'm not actually interested in the actual values, but I want to put them in different bins. Like this is a low value, this is a medium value, this is a high value. Because the actual numbers is not so important at this moment when I do this analysis, but I want just get a rough picture. Have a low, how many low sales, high sales, medium sales do we have, or whatever your bins might be. And there's two ways how we can model this. One, we can actually use relationships, and this is then faster, but then we have to build a table according to the different bins and different values we have available. We'll see in a second. Or the other one is then using this detached table approach, where we can just provide the low and the high range of the bin and then make sure that DAX covers for this more complex relationship. Let's jump over to the next demo. So close this, and then I don't want to save this, and we go into binning. This is in DAX, and then I have it with binning. Here we go. It's about time to up the Power BI desktop again. This week I discovered I still have the August version, and I think the November version should be out soon. So let's see what kind of model I'm having here. Again, this is the simple model, very simple model. Again, with the same, maybe the data is different, but it's the same idea. Like we have 4 sales with different quantities and total costs. We have 4 products. One product, there's no sales, and there's different sales for different quantities. That's what we concentrate on next, and then there's a date table. And then that's the goal. Like I want to have like my products A, B, C. That's the names of the products, and then know how often was this sold in a low, middle, or high quantity. So A obviously only was sold 1 in the medium and middle quantity. If you see here, the quantity is 3, and according to my bin table, 3 means middle. And B was sold in low and middle 2 times, 1 more low, 1 middle. So as you can see here, 1 and 4, and 1 falls into the low region, and 4 is middle. And C is then in the high. Only 1 says they are high because 5, according to my table, is high. So that's the idea of coming up with an analysis like that. And we already see the first solution. So the first solution is that you could come up with a bin table, a table with all the thinkable quantities, and then assign different values to them. So this is rather, it's rather easy to build. You can just come up with an Excel file, right? And then type in 1, 2, 3, and then like add it to, I don't know, 100, and then you copy this low value for the first 20, and the medium for the next 30, and the rest for the higher whatever. So this is easy. It's not complex to maintain. It can be like awkward because it's a long list of values, but it's rather easy to do. And then we can join those 2 tables on the quantity, which is maybe an unusual idea because usually we join things on their ID, right? And the quantity is not an ID here, but we can use this. So for example, one solution here is this bin table, is that we have a relationship. I have a relationship here on the quantity. So the quantity of the sales table is something I can also aggregate on, but I also use it to have the bin table associated with that, and then I can show the bin from this bin table in my report as I just did here. So this is one way. This only works if you have a distinct list of values. So if you know what kind of values could appear, maybe for the quantity, maybe it's not always clear. We can be sure that there's no zero quantity, there's no negative quantities. Sometimes you have like if you have returns, they're sometimes in as minus. Then we would have to add this in this bin table. Maybe we know that the maximum of quantity is 10 because our system does not allow us. Then we could like provide for 10 values, or we have to be careful like here, so to apply as many quantities as there could be thinkable of. If we miss some, then Power BI and the word packaging is very forgiving. So if there's one quantity, for example, this list stops with 6, right? If I would have one sales with a quantity of 7, then this will show up with a blank product, with a blank bin. So everything which is not in this table will not be missed, because Power BI Word Back Engine is always doing a left outer join automatically. There's no other way around that. And we will not lose this, but it will just show up with a blank. So as soon as you see those blanks, then you would have to maintain your bin table again. And the bin table can be built in various things. We already talked about DAX, show the solution in DAX here. So we can create this bin table in DAX, which means that I just go over my jump over my, where's my mouse cursor? Here's my mouse cursor. So I get the distinctors of my quantity, and to this I then add a bin column. This add columns and adds this bin column, and that is just a switch, right? So I check if true, the first element is true, then the next will be compared to true. So if sales quantity is lower than 3, if this is true, then the content of the bin will be low. If it's like lower than 5, should also go below than 3, but the switch statement would stop here, right? If it's lower than 3, if it's lower than 5, it will return middle, and for all the other one, it would be return high. So even if you have like a value of, I don't know, 20, it will appear on the high. If it will be 0 or minus, it will be associated with low. And then I can then also add a sort order, because I want to make sure that it's not alphabetically sorted, but that it's sorted by whatever the lowest bin in there is. So of course low should be first, and then middle and high, and this is what this makes out of that. So I'm looking for the minimum value inside of the bin, like 1 or whatever the value is, and this is then associated to low. So this is the table coming up here. This table has two disadvantages. One is, looking at it is a little bit weird because there's gaps, but those gaps are no problem at all, because these gaps result in gaps in here. We don't have a quantity of 2, so I don't need it in the bin table. As soon as there's some sale appears with a quantity of 2, this will be automatically added here through the refresh. The other disadvantage is that we are now scanning for this bin table, creating this table. I'm scanning the whole fact table. And of course, in this case, the sales table is rather small, right? So there's no danger in that, but usually a fact table can be huge. So building up this table this way could be a bad idea if this is like millions, billions of rows. So be careful with that. So if the table is too big, and or we cannot provide a distinct list of those values, think about if it's not a quantity, or if it's a quantity but you sell goods like in kilograms or liters or milliliters. So there could be an endless number of amounts or numbers in between. And then we cannot use this, because then building this bin table would be impossible. Or the bin table would be really big, and still there could be always one value in between. So then we can jump over to the other solution. Let's concentrate on this table here. This is the bin train table, where I just provide a table, and this can also be maintained by the end user, Excel or whatever, where we say, yeah, I don't care how low it is, yeah, but if it's up to 3 and 3 is not included, so 3 is already middle, right? But up to 3, like 2.99999 would be just lower than 3, then it's low. If it's between 3 and 5, 3 is included, 5 is not included, then it would be middle, and 5 or whatever higher the number could be, I don't care, it should be in the high region. As you can see here, the solution ends up with the same result, so it's working fine. But you can also see that there's no relationship between the bin range and the sales table. How could it be? Because we are now looking for quantities which are in between the high and the low value, and there's no way of specifying something like that. So this Word Back Engine does not allow for having a relationship which is not based on an equijoin. So we have to maintain a DAX statement here. So this bin count is the values we're seeing in here. And if we take a closer look here, I'm using this sum x to count. That means I'm getting a sum x takes a filter, a table expression, and for every row in this table, whatever this expression returns, we get the value of 1, and then a sum up 1. So I'm counting. Sometimes this is a little bit faster than just applying a count. We could also have a count on this filter that will also work here. And then we have two filters. There's one filter in here, there's a filter in there. Let's take a look on the inner filter first. So the bin range table, this is this table. So this filter is iterating over this table and now deciding on what kind of row or rows, it should return. So this is the bin range table, and then I have a long expression here. This is going over 3 lines, but it is connected with this Boolean AND here. So if the quantity is blank, yeah, I'm not interested, because if there's no value available, then I'm not doing anything. But if it's not blank, then I'm looking for if the quantity is bigger or equal to whatever the low range is, like if it's bigger or equal to this blank value, or if the low value is blank. This would also be okay. So if the low value is blank, it should be applied to all quantities. And if the quantity is lower than the higher value, so for example, for a value of, what do we have here? A value of 2, this will fill lower than 3, so it will fulfill this. So it would survive this condition, right? It would also survive the other one. So this line would survive the other one, because it's not greater equal than blank, but this thing here is blank, so it will then return low. So this expression returns then one line according to where the quantity falls into, and then this variable is checking if whatever is returned from here, if this is non-empty. If it is non-empty, then we have found a value, right? And then it is in the bin, and then we can count for this bin this value. So, hope this makes sense. If you've never seen DAX before, this might be a lot of information or a long statement here, but this is understandable. So to say, you can learn this. There's ways around it, but this makes it possible to have non-equi joins. Okay. Any questions to binning? And then a question: how much time do I have left? I think it's until, is it 10 or 5 past 10? It's like I have 20 minutes left. All right, is this right? 20 minutes left.
Yes.
Okay, very good. So we can concentrate on the next one. So this is, I mean, it's never enough time, right? But it's more than enough time to show you the last example about the key value. There's no question so far. Okay, so key value pair model. What is the key value pair model? A key value pair table is a table, basically, theoretically, with only 2 columns. There's a key column and there's a value column. And those pairs, that's why it's called pair, key value pairs. Pairs of those 2 columns. And the key would be an attribute. Like the key would hold a string containing name, birthday, whatever, as a string. And the value would then show the value for this key. So for example, if the key is name, the value could be Markus. If the key is birthday, then the value should contain some date in a date format, right? Indeed, it's more than those columns. Usually you also have an ID column, which groups those ways, because maybe there's more than one person, right? And if I just have name Markus and name Andre, then I'm not sure whose name belongs to whose birthday. Yeah. So I want to group those. So I also have an ID. So maybe Andre gets the ID 1, and the key is name, and the birthday is something. And that is an ID 2, and with name, and then Markus, for example. Hopefully, there's also a type descriptor which tells us what's the data type of the key. So for the name, it will tell us this is a string. For the birthday, it will tell us this is in a date format, or in a certain date format, maybe, if there's different date formats available. If it's the salary or the revenue or whatever, it should tell us this is a number, a whole number, a decimal number, whatever. We can be very flexible there. We come back to this type descriptor later. The thing why this can be found, or why this is used, is extremely flexible, as you can see here. Like within a relational database, which has a schema, right? We have a key column and a value column. This is a schema, but still there is no schema, because the data itself, the information itself, is stored not in the schema, because I have a key, it can be of any type. Well, the key is a string, right? But the value for it can be of any type. And if there's new values, new attributes we want to store in this table, it's just easy, because we just add a new line. So for ID 1, we now store whatever text paid, whatever the information is. So we don't have to change the schema. We don't have to change the table, the structure of the table. And that's why this is liked or loved by application developers, because they might think of the database just a stupid store of data, of information. They don't care too much about like maintaining a schema. They only see the troubles in maintaining a schema, because that means that they have to roll out the application, but also have to roll out the database changes, which might be very complex. Or some applications just need a framework between the application and the database. So the application developer does not even know what's happening in the database, because it's just calls or methods of a framework they're using. So I totally understand why this is the cool approach, because it gives us a lot of flexibility. But the backdraft is, it's extremely hard to build reports on that. As we will see in the demo, usually we need to pivot this information. So instead of having a row where the key says name and then we get the name, we need a column called name and then see the actual names of all those people, of all those IDs, right? So we have to change and transform this model. First, we have to transform and pivot this table to get it everything which is in rows into columns. This is called pivoting. And on the other hand, of course, afterwards we have to rework this as a start schema. And the use case I'm coming up here, or why I'm having this talking about this, is an actual use case I had with one of my customers. It's about insurance, and they have an application available where, like, if you have a claim, if you say, I'm insured for this and this thing, and then they claim the insurance. I say, now I can't work anymore, so I want you as my insurer pay me all the money promised, and then they have to fill out things and forms. And depending on the answers, they might ask different questions. So they have like a rule book, which is a secret rule book. I didn't see the rule book. There's very secret, big secret there. And so the rule book might ask, I don't know, maybe 1,000 questions. So when they store the answers, they didn't come up with like a broad table with all those columns, but they decided for having this key value pairs. So depending on what kind of answers they get, they might ask different questions again. So like the list of questions and answers per insurer, it's a patient. What's the term in English? I can't remember. So the one who claims the insurance, the claimer, might be different. And they didn't want to change the schema. And this is so flexible that it even, if I look at the data currently now, it does mean like we have like 800 attributes or keys available there, but tomorrow there could be another attribute there again. And when I started with this project, I just began with like defining a table with 800 columns and pivoted everything. And once in a while they asked me, there's some information missing because there's new attributes coming up, and then I had to like rework the model, change the data model, change all the ETL process, change the views, change the model analysis services, and change the report to also show this information. And at some point in time, I decided this is not scalable, right? I mean, I love to be engaged and like have work, and I can bill hours for all this work, but this is not scalable. I want to build up a solution which is do this more automatically. And this is what I will demonstrate here. I think for today I will show like the solution in Power Query. 50 minutes left. In Power Query, actually for the customer, I built this in SQL, and also for this kind of demonstrations, I also have the same available for DAX. But I think today we stick with Power Query. That's what I decided on here, and which does this semi-automatically or even automatically. So creating all those steps in between and doing all those pivoting. But let's see what we're coming up here with. Again, close this demo file, and then no. Not saving anything. Then we jump up here to the key value, and then we have the key value example. Yeah, 800 columns, yes. And it's ever growing. I mean, this is just at the very moment, and tomorrow it could be 805. How did I make your model on the 800? It's too much to manage. No, actually it isn't. Yes, that's what I also was afraid of that, like having a table with 800 columns, but it's working. It's working fine. It's analysis services, and the performance is is okay. I mean, we're not reporting on all of them, so there's mostly the measure is counting on things. So they want to know how many people claimed because of knee problems or back problems or mental issues or whatever. So mostly counting on things and setting filters on those attributes. And on top of that, it's also a multi-language model. So we had like to, I also came up with, for the same customer, that like the report viewer can change the language they want to see the report in. So all the headers change, but of course also the attributes change. So knee problem in English is a different term than knee problem in German, as you might guess. So depending on whatever language they choose, to be sure either knee problem or Knieproblem in German or other language. So it's a rather complicated model, but performance is fine. It's okay. Yeah, 799 would be okay, but here it's just too much. Yeah, I mean there has to be a limit, right? There has to be a red line. The 800 is just too much. I totally understand. Yeah. So let's take a look on this table. So this is this key value table, as I just tried to describe in words. Now we see this key city, for example, value Seattle, key first purchase, and then we have a date in here, name, and then I group those by different IDs. So obviously this is a different person from this person or from the other person. The cool thing I discovered here, I never thought about that, because usually I get it like already in columns. I don't get it in lists, or like up to this point, I didn't have those challenges that much. What we can do here is that we can come up with a matrix like this. So I really like this idea. Now I even have this like in my book, so to speak. This was the wrong thing. I wanted to click like that. So zoom in here. So what we see here is that I get a matrix here where I see the names here. So for the rows, I selected names. So I see there's different names. For the columns, I see the different cities, Arco from Seattle. I see the totals again. And then we see counts. So I don't see like what they earned, but I see counts here. But with this kind of model, with this key value, as everything is in rows, I could put things up there. So can I, for example, change or add the first purchase here or remove the city here. So I, as a user, can now change the look and feel of this table, what kind of information I want to see here. Or I could just add, for example, the name and then also the, what do we have here, the city down there. So now we see like in Arkoven we had one sale on this date, and there's one Markus also sold some, bought something on this date. So this is rather flexible, and building up this, I increased my problem of having this one key value pair model or table. I have two of them now. So for this, I used one slicer on the key column of the key value pair, right? And then I duplicated all the information, did a filter on the key of the other source table here, the key value pair model, and here I use the values either from the one table, source 1, or the source 2, and then count the IDs of one of those tables, and I combine them in a data model with a many-to-many relationship with bidirectional filters. So it always gives me a heart attack if I see what I did here, but if the table is not too big, the performance is also nice, and this gives for really flexible reports. But that's not the usual thing, right? Usually we have to build up something like that. I want to have all my customers, whatever. I want to see the attributes. I want to see the revenues and so on. And the backdraft here, as you can see here, there's like the revenues left assigned. This is all unusual, right? Because the revenue is a string. Everything is a string. The value column, there's one column value, contains all the values, right? And the thing in common for everything is to have it as strings. So if I could add a total here, but the total would not allow me to sum something up, to show like the minimum value or whatever. So this does not work. We have to do something here. And I think we jump to the Power Query, because I think the Power Query is the most useful here. So with Power Query, I managed to get actually the revenue as numbers, see the total down there, and get the different date types right. And let's see what I've left with this 10 minutes I've got. So let's jump to Power Query Editor. So the source table is the source table as I get it, like the ID, the key, the value, and the type. The type is not very important. What's the content of that? Here, I use the data types of Power Query, but this could also be like 1 means text, 2 means whole number, and 3 means date. it's not very important because we can react to that. I just wanted to make in Power Query to understand what the data type is, so I use the data types of Power Query. And when we want to do this, then I would have like, I would reference this. Of course, I can always reference this and then jump to my key column. Let's see if this is working, the key column. And then I always struggle with pivoting in Power Query, but also in SQL. So I think I have to choose here the value, and then I can pivot this, right? So now we should get a table with like the IDs. The data type, I would have to remove the data type first. So ignore this, remove this, insert, and this still works. Yes, then I get like one list, 1, 2, 3, and I get like, come on. Don't have so much time. I want to have like the, because like the value, there could be, what if for ID 1, I get 2 names? What shall we do? And I just pick one, right? I pick the alphabetically first one. Now we get like Bill and Seattle and the revenue and everything. And then I can jump here and say, okay, revenue should be a whole number. And the first purchase should be a date. But I don't like that because then if there's a new attribute, I have to go here, find out that there's a new attribute, and then I have to, the recording stopped for some reason. Okay, I had to start it again. Okay. Then I have to go there and maintain this again. So what I came up with, and this is good for the last couple of minutes, is this solution. So I have a Power Query script, which is rather long, as you can see here, applied steps. And the first steps are the very same, what I just demonstrated. So I have like the source in here. I remove this type column. Then I change the data type to make sure that everything is a string here. Then I pivoted everything on this key. And then I do not stop here. And I do not maintain this manually. But now there comes a step which is independent from the other ones. I then get a list of my data types. So so this is not doable with the UI, so you have to write M code here. And what I'm doing here is I get the keys and the type column and list this up. So I get now my name, the name is a text, city is a text, revenue is a whole number, the first purchase is a date, and the zip is also a text, right? It's a number, but it could be also contain text parts. And then I have group of 4s. So I have text rows, text row keys, text columns, change type. Int, whole number, rows, blah, blah, blah. So it's always group of 4 things which are connected. And if we think about like the revenue, which is this int data, let's jump here. So in this step, I limit all of my, of these column types, right? The column types, this list is now limited to all of them which have a data type of int64 type. As mentioned, this could also be like 3 for whole number or whatever. Yeah? The important is I'm filtering on those rows which contain everything which has a whole number. And if like the source table has here 3, then I would filter on 3 here. And then I limit this to the keys. I'm not interested in type anymore. I just use it to filter down. So I know now all those columns in the source table which are a whole number, which is revenue. I then convert this into a list. It's a different data type in Power Query. And this I can then use as a parameter in this change type step. So the transform column types allows me to reference to some other steps in here and then transform everything into a int64 type. This is the data type. Now it has to be specified that is int64 dot type, because this is the way how I define a whole number in Power Query. But I'm referencing to my int64 type columns, to the step before. So I'm now asking for all those columns named, for example, what was it, revenue, please change the type to a whole number. And this is what I then repeat for all the thinkable data types I have in Power Query. So a number, currency, percentage, date time, and so on and so forth. So in the end, I don't have to do anything, but just use the table. So all the data types are now in the right way, depending on if I get the data type, of course, delivered right. But this is not usually not a big of an issue, because those applications using this key value pair, they also have to store somewhere the data type, because they use it for UI, right? If it's a date time, they want to show a date picker. If it's a number, they want to make sure nobody types in a text, because it doesn't make sense also for the application. So usually we can depend and trust what we get delivered there. And this solution I originally built in SQL. So in SQL, I use also this pivot and use dynamic SQL. So I build up my SQL string to first create the table where I can then, the pivoted table where I can host everything. I dynamically build a procedure which is doing all the pivoting and loads everything from the key value pair to my new table. And on top of that, also creating a view, which I then use to expose to analysis services or to Power BI to read in the data. So this is just, it's semi-automatic. That means I do not run this procedure automatically every night, but only if people ask me. Maybe we could also run it every night, but I didn't think about that. But it helps me tremendously because if somebody complains about there's some attributes missing, before I had to walk through a lot of code and test it and maintain it, and not just calling one procedure with a couple of minutes and deploy the changes and everything is done. And I can also trust my procedure because now everything is done in the same way. If there's some problem with the procedure, if I fix it, it's fixed for all the data types, it's fixed for all the future again. So I can mix more trustful code, I would say. Okay, any questions about this key value pair? Okay, so this is just sums up what I just demonstrated for the sake of usually spend a little less time so I can end in time, so we don't get the organizers and all the people involved here into troubles. So sum it up, takeaways, please take care of the data model. It's very important. Respect the data model in Power BI because Power BI is a model-driven tool. Don't load one white table, don't load a normalized schema. Please respect the star schema. So stay away from the many-to-many, stay away from bidirectional filters, prefer the star schema, unless you're really sure that you have one of those edge cases. And for those, we have the bidirectional filters. For those, we have the many-to-many cardinality. For those, we have a function like treatise. But it should not be the normal way of doing this, but only if you have those edge cases. And we also have seen that we can exchange complexity in the data model, like building up things in the data model or building up in DAX. So this is like, in many cases, interchangeable as DAX and the data model go very, very tight hand in hand. Yeah, Power BI and also our services optimized for the star schema. I can not repeat myself too much in this here. And any questions? And then I think I give you one back 1 minute, right? Okay, doesn't look like there are any questions. So I can hand over back to Hassan or to the next speaker.
Thank you, Markus. Thank you very much. It's a nice session and we have enjoyed it.
Okay. And tell it, Hayab.
I
think we met. Hayab and me met at the SQL Run in Pass Summit a couple of years ago, or several times maybe. I can remember that we took our tour an early morning in Seattle. Yeah.
Yes, and I'm looking forward for next week.
Yeah, I'm not going to Seattle next week, unfortunately. I'm doing a remote session, which is pre-recorded, so I'm gonna stay in Austria. Yeah. Thank you very much, and have a nice SQL Saturday, and enjoy the next talk. Bye bye.
Thank you very much, Markus. Thank you. Assalamualaikum, bhai.
Walaikum salam.
Just I'm taking 30 seconds for stop recording and trying to start it again because
Sure.
a few session has passed and